So, welcome everybody to Lecture 5, Databases and Information Systems, the last time 2025. Next lecture 2026, I will say something about your experiences with exercise sheet 8, which was fuzzy prefix search, and today we will talk about web applications. Today and in the next lecture it will be very live coding heavy, pretty exciting stuff, and you have to help me. And the exercise sheet for which you will have 4 weeks, so start today. You have 4 weeks, there's no lectures for 3 weeks now because of the long holiday, is to build a first small web application. And it will be 2 parts. Today we will do static web applications and I will tell you all about it. And then for exercise sheet, this should be 9 and this should be 10. We will make them dynamic. And this should be exercise sheet 8. It's the last one. Great assignment. I like that we revisit the inverted index. So that was a fuzzy search. So after a lot of databases and then 1 lecture on knowledge graphs, we did something else. Fuzzy search, but it all belongs together, as you will see today and in the next lecture. And for the QGram index from the last lecture, we used the inverted index from the first lecture. So you will see, I mean, these are different topics, but there are underlying topics which are recurring. For example, the inverted index, you basically have it everywhere. I truly appreciate that the sheets are built on the lecture for those who do the sheets. I mean, they are very tightly coupled and we put a lot of work into that. Getting my hands dirty while implementing everything from scratch is really fun in this class, encourages me to grasp every detail. Was very happy to read that because that's really the motivation for the exercises, to not just understand it on a high level, but understand the detail. When you move your chair, I recommend lifting it, moving it, putting it down. It creates less noise that way. Very rewarding to see the query working at the end. For me, it was a nice sheet, a bit tricky, but not too tricky. That's the sweet spot, I would say, more challenging than the lectures before, but I liked it a lot. It was a bit more, there was a bit more theory in it, but it was theory of the kind you needed, right? I mean, you have to say, we had to filter out these things by QGrams, and you have to know what the bound is so that you don't miss anything. So all the theory we had there, we needed it. Otherwise, and in the end, you just implement the formula, but you had to prove it first. The hardest part was figuring out how to query the index. The index itself was pretty straightforward. We did that in the lecture. How do you actually use it? You use it for throwing out candidates and then evaluating the expensive edit distance for the rest. Text on the sheet was very long, but that is a good thing. I talked about that, like very detailed descriptions. Why is earn missing at the bottom of the exercise sheet? Let me just show that. That was, there are always these trying to be funny, please turn around notes here, and that was prefix search. So it's please turn over. So the final QGrams are missing. It's just a prefix, so it was not an omission. That's also exercise sheet 8. Why do only 20% of you submit exercise sheets? We got some interesting answers here. I've stopped 2 weeks ago because of lots of other stuff. Most humans prioritize short-term enjoyment. As such, we need to get forced what's good for us. That's why many do it mandatory. We waver between the two from year to year. This year we did it like this. Some people just don't care that much and take the easy route. Only course with non-mandatory exercises in the 3rd semester. Okay, that's a strong. So in the 3rd semester, people who are now in the 3rd semester, they hear other lectures. If they are studying according to plan, they are all mandatory. And if there's one where it's non-mandatory, you skip those. That's an interesting argument. I was part, that's part. Robin, can you take notes of the small mistakes so that we can fix them afterwards? Of the 80%, I'm trying, so we convinced some people to switch to the 20%, which then become more than 20%. I learn way more efficiently and thoroughly when I learn all of the stuff concentrated in 1 week at the end instead of a bit every week. So there was a variety of opinion. I totally respect that. let me say from experience with very many students over decades, I believe that there are such learning types, but be very careful and critical of yourself when you say this about yourself. Maybe you're one of those, I can believe. There are people for which this is true, do it very concentrated in 1 week. I can tell you for most people it's not true. It's very easy to delude yourself. So for this person, I think I believe it. They wrote something pretty long and convincing, but it's just not true for everybody. It's like dieting when you want to lose weight or stuff. I mean, it's just super individual. Some things work for very few people, some for more people. I think this just works for very few people. But I respect that it does for very few people. Fungi are kind of awesome, and people like the number 7, 3, 4, 12, and 13 a bit too much. I thought about it for a while. I didn't understand it. Is this something which I'm supposed to understand? It was late when I read it, but maybe if you find out. Okay. So let's start with today's lecture, which I need your full concentration. I also need my full concentration. I'm not sure if it's challenging because we will build a full web application, a simple one from beginning to end, bottom up from scratch, not using any libraries or anything. And it starts with socket communication. Let me just say that first. It's very easy now to download the library which does everything for you, and then you just call one program and it all works. But obviously that's not what we want to do in this course, right? We want to understand it from bottom up. So we will also write it from bottom up. And that is just, I mean, at a university, that's what you're supposed to. You are supposed to understand all the levels. We will not start at the subatomic level. We will start at the network level. So network is given, TCP, we will not talk about that. So you have a network connection between two machines, and now two machines talking to each other. How do you do that? So you have, so here's some example. A browser is running on your local machine, your smartphone, your laptop, and then you have some machine somewhere serving the pages. And so they are talking to each other. And when two machines are talking to each other, there's a communication channel, and these two endpoints of the communication are called sockets. That's very important. That's a low-level term. You have a socket here and a socket there. And it's important, two machines, can have lots of communications. A bit unlike humans, who usually only have one channel, so a machine can talk to 20 different machines at the same time. Then it will have 20 sockets for that. And that's because you have multiple channels. You do not only have to identify the communication channel, of course you need the name of the machine, but also a port. And that's just called port, which is a number. So I'm currently talking on port 3 to that machine, on port 1315 to that machine, and so on. And we will see all that. And here's the basic protocol. So you are the server, you are the one getting asked, like the call center or whatever. You get a request, you create a socket, new communication channel. It gets a certain port, which is for that communication channel. You wait for stuff to come in. Somebody calls on that port, you hear what they have to say, do something with it, send back the result. On the client, you say, let me call up that machine. You also need a port for that. And then you send them something, you wait for them to send something. And how do you do that? In Python, there's a library called socket. In Java, there are also other libraries. Let's not get into that. C++ is the most complicated. There's the most low level. We have used all these in the past. For the lecture, we will just use socket. But we will use, it's a pretty low level library. And so what we will do now, I will start from some very basic code. We will just give you that code for the exercise sheet. Not everything we write today, because then the exercise sheet is half done. Let me just close all this here. And let's just start. So what we see here is already in the... let's just start. So I've prepared something. And I have a number of windows here I will explain as we go along. So this is, let me maybe go back to the slide one more time. This is now the machine which is like the call center which gets the calls and response. It has to create a socket once, and this is how we do it in Python. You're creating a socket. Let's not get into these details, but you already see it's pretty low level. It's we want to reuse it. That's important just in case you stop the program and then you want to reuse the port for the next. If you don't do that, you can't reuse it. The system will say this port is already used. This means anybody can connect. Any other machine, 000, this is low-level network stuff. Your machine has a name, that can be a name, an alias, it can also be just the IP address. This just means however other people call you, they will always reach you. If you write a particular name here, they can only reach you under that name. If you write a particular IP address here, then they have to call you under that address, right? The same machine can also have multiple addresses. And then you just listen. So this is what you do, and this is already prepared. And then somebody, we will get into that. So that's the basic, the start. So I have a class here, search server. I call it search. It's really just a server. You will use it for search. We have a port. That's the port on which we are listening. As the server, the one answering requests, we only have one port all the time. That's why we are listening. And these are the commands which we have just seen on the slide. So right now, and we can just do that here, we can just start it. So that's the basic. Am I on the right search server? Okay, here following arguments are required. Let's take 8888. That's a typical test port. So we will be listening on 8888. That's it. Okay, so it did something. It created the socket, was listening, nobody was talking, and then it exited our first server. Okay, so the first thing we should do is we should do something. If somebody, we should wait for somebody to call us, right? If we don't do that, so what you see here already, none of this is blocking, right? It's just doing something and then moving on to the, okay, so let's, so this is now the server loop. Oh, and by the way, the main function, it's nothing special. I also wrote it, just adds an argument for the port. You just saw this here, it's just the first positional argument. You create the server, and then you run it, which would call this function. Is everything clear until this point, just the basic setting, or any question about that? And now, bit by bit, we will just do things and see what happens. So the server loop. The server loop, very often, it's just an infinite loop. I'm just there, I'm now server, that's my destination, my destiny, and I'm just replying until the end of time. So it's a kind of hell or heaven, depends how you see it. Okay, somebody says it should be 8080, not 888. We can do what we... Okay, so wait for incoming requests, so for somebody to call us. And let's just do that. So, how do we do it? Let's just waiting for connection on port. Let's just do it that way. On port, self port, How do we do that? That's also written on the slide. So we're just accept, and that's blocking now. So if we just run that, I think it will be, no, it's not. Okay, it's not blocking. Let me go back to the slide. No, I'm surprised. Why is this not blocking? Now I'm already confused at this early point. I was expecting this to be blocking. What did I do wrong? Robin, what am I missing? No, it works. I just didn't start. I didn't save. Waiting for a connection on port. Okay, I thought I'm misunderstanding some basic things. So now I'm waiting for a connection on port. So this is blocking, accept. It doesn't say wait, it says accept. Now I'm waiting for someone to call me, right? And then as soon as they call me, I get their socket. So go back to what I just said. So I'm on this machine, and this machine is called Tura. So that's just one of our machines. And now I'm waiting on somebody to call me. So I'm on Tura, I'm the server, Tura, port 8888. And now somebody on some other machine anywhere in the world can call me. And then when they call me, I get their socket and their address. And let's maybe print it when, from client address. And let's just see what's happened. And let's do this. And now let's call this machine. And now I have a third window, which we didn't have so far, and it's here. And it's deliberately on a different machine. That's now Amor, it's one of our machines. Different machine could be a machine anywhere in the world. How do we call Tura now on port 888? Well, there's a very old program. I mean, there are even older programs, but it's called Telnet. It's how in the 17th century you used to call other machines Telnet. And it's very simple. It's like a telephone. It's just say, call this machine. This is now a local network, so I don't need the full domain name on this port. It couldn't be any simpler. And you might want to use that for testing, for playing around. So now I'm just calling up Tura on port 888. And you see something happens here. Connection from, so this is now, it's not Amor, it's the IP address of the machine. And that's the address, which we just saw in the code. It's now on this machine. That's the name of the machine, IP address, and a port, 34600. This was now created automatically, in this case by Telnet, right? This machine now wants to talk to us, and they now also have a sec. So let's, let me talk. So what's happening here? You tell me. Well, nobody, I'm talking to the other machine. Well, what happened here? Yeah?
I think the socket is established, but you're never reading from the screen.
Yeah, you're never reading from it, right? I mean, we are already waiting for the next connection. And that's the first thing to understand. So connection, this is asynchronous. So I accepted this, and this is a while true loop. I just moved on. I did nothing. I wasn't even listening. Now, and this is the thing with network communication. It gets tricky really fast. Here on this side, I don't know what happened over there, right? I called them, they accepted me, now I'm talking to them. Didn't get any, I don't know, but they are not even there anymore. They already moved on, right, away from the phone. But the connection is still there. So I can talk here forever. I will not ever hear any reply. And this, if you have this in a program or complex program, this, it can be hard to understand. And absolutely for the exercise sheet, you should also start that way. Do it yourself, understand what is happening, try all the things that can. So now I close the program, and now they realize that something happened, because now I killed my whole socket, right? Okay, and if you have any question or want to try out anything, we can do it. So next thing we should do, we should actually read what they have to say. So read. And some of what I do now is on the slides, but we will just mainly code, and then the slides are for reference. Sometimes I will go back, but mostly I will be here. So read incoming request. And now that's one thing. When you read something, now a good analogy is when you hear somebody talking. Somebody calls you and they say something. They will say something, then they will make a short pause, then they will say something again. So they don't send it in one go, but they send it like in packets. And you have to somehow negotiate when they are done talking, right? How do you do that in human communication? I mean, you could say something in the end, like, I'm done, now it's your turn. It's not how humans do it. Usually you make a pause, right? You make a pause, and then you know the other person is done, and now it's my turn to speak. And the protocol we're using now is very similar, and the pause will just be a new line until new line, an empty, until the first empty line. And think about it, I need to know when the other person has finished talking. Incoming request in rounds until the first empty line. So how do we do that? Let me just, so the request. This is a byte string, so we are reading bytes, raw bytes. I have something on the slide for that. And now while, and now here's another thing. So what's a new line? This could be a new line. But the thing is, in this protocol we are talking about, so new line, that's just a new line character. But actually, there are two new line characters. This is, oh my, this is, I have to make this a little bit larger here and then maybe smaller again. So the new line is, where's the new line here? Which character is it? This one, right? Yeah, that's the new line. 10, line feet. Is that the new line? Yes, right? That's the new line. But there are kind of two new line characters, line feed and carriage return. And now you have to go back in the ancient past, typewriters. You know how you get it, a new line in the typewriter? You first have to brrp. Now you get the paper one line further. And then there was a carriage that when you're typing, it like moves like this over the page. And you have to return the carriage, right? So that it starts again in the next line. And you still, this is very funny, in case you didn't know that, you still have both of them line feed, like brrp, next line on the page, and then return the carriage to the beginning, because it was now at the end of the line. Carriage return. And you have both of these, and it's, and actually in the HTTP protocol, which we will talk about in a second, this is the new line. Carriage return, new line. Is that the right order, or is it the other? I think that's the right order, right? So, and that's still the convention in HTTP. So in web carriage return, yeah. And sometimes it's just the one. Typically nowadays they are all implemented that only new line is enough. But yeah. So while, is it not in, yeah, let me just, no, I think I should do it like this, while true, and then now I should request plus equal, yeah, let me just receive something. How much do I read at a time? Just let's say, yeah, that's fine. And now if I, okay, here it's in request break. Okay, let's just do it like that, and then let's print the request received, and let's print it. And this is already non-trivial. You can do a lot of things wrong here. So let me and let me, okay, now here's another thing. So I'm receiving this as a byte stream. I want to interpret it as a string, so I have to decode it. Let's maybe go to the slides. So this is what I just said, read in rounds. Do I have to bytes versus strings? That's also super important. Raw data, you typically read it as bytes, and you do that with this B here in front. So these are called byte strings. When you interpret them as something, you have to say how you encode things. Yeah? For example, here we have Knödel, Ö, the German umlaut Ö. How do you write it in a byte? In an ASCII character, you can only encode so much. For example, in UTF-8 decoding, in UTF-8, there will be a whole part in the next lecture about this, is how you encode funny characters as bytes. So Ö, for example, is these two characters, C3 and P6 in hex, and you can convert back and forth with encode and decode. For this lecture and for the exercise sheet, just use them and just understand that there is bytes, raw bytes, 1 byte for each thing, and then when you have a character sequence, 1 character can be multiple bytes, and you have to convert back and forth. And converting 2 bytes is called encoding. Converting from bytes to something with characters is called decoding. Any questions about that? That's just this simple level for this lecture. And there are many different encodings. We will talk about them in the next lecture. So now I just received bytes, and we have to agree, of course, what language do we speak. We just say it's encoded in UTF-8. So let me just request decode. So now it's UTF-8, because otherwise I will print a byte here. Yeah. Okay, request here, and let me maybe, if there's a new line in the end, let me just strip it. Let's try again what happens now. Let's start our server. It works, compiles, and now let's so hello. So what's going on? You tell me. Yeah?
I think you're listening for 2 new lines. Look in your code again.
Yes?
I think you have
Sorry, too many windows? Yes?
you have character to a new line, character
Yes.
to a new line in request, so you need an empty line.
Exactly. This is what I wrote here. Exactly. This is what we want. That's the protocol. So I need an empty line. Before that, nothing is sent. It's actually exactly what we implemented, right? So I can write multiple lines, and now it's here, right? Now it was sent. And I stripped the last new line. And now it went on to the next connection here. And let me just print maybe here and just an empty line. And it's a bit nicer. Everything clear so far? Or any questions about this? So I can type a lot of things here. And as soon as I first empty line, now it's there, and now, yeah. So, but it's still something missing, right? So it's with typos. So this already moved on. So we have the same. So but this part worked now, right? And still, this over here, this poor fellow is still unaware of some response. This has now already moved on. I don't know it. But after the new line, at least it was sent, but I don't know it. So now we have to send something back. So let's do that. And please ask if you have any questions. So now let's handle the request. Handle the request. And let's do that in a separate function. That's what you typically do. And let's call it handle request. Yes?
Question. If you were to buffer the request on the sending line, then it could be possible that if you're sending multiple requests at once, that the buffer is aligned so that the breaking character, the line is in between, but then you're like splitting, you're not properly splitting the request.
Okay, now you're saying multiple requests.
No, I meant if you're not like using Talent, but programmatically
Yeah.
sending 2 requests and if
From 2 different machines
no,
now.
from one machine, because in your code you're checking if an empty line is in the request, but there could be information after the empty line. That's the question, if it's possible.
Just a minute. So I think you were asking 2 questions. So everything after the empty line gets lost. That's correct. That's the way how I implemented it. That's just the protocol. The protocol is everything until the empty line. It's like you're talking, you're making a pause, and then you are still talking, but now the other side is talking. They're not listening to you anymore. That's just our protocol. You could do it differently. Now you were also saying many things. Just to be clear, this is a communication channel now with just one person, right? And that's let me just clarify that. So right now, if somebody else wants to call us, they we are busy currently, right, with this one. So the way we do it now, everything is serialized. So the next one will only get in connection when I'm back here again. Until then, they will have to wait. Is it good enough for now? Or do you have okay? So let's handle. But these are all very valid questions, and multiple machines calling, doing this in parallel, blah blah blah. There's so many different things. So we call the function for handling the request handle request. Exciting, and we send it the request. Self handle request request, and let's write the function for that. And it's called handle request self, and it gets a request string, and it sends back a string. Okay, so this is do we need documentation for handle request? Documentation is handle the request. Okay, so what do? We need a response, and let's just be very vogue and friendly. Let's just say thank you for request. It's our reply. So we are just polite, but we're actually doing nothing. Thank you for request. Auf Wiedersehen. How about Auf Wiedersehen? That's from Django Unchained, I think. In case you want a movie reference, Auf Wiedersehen. Thank you for request. Auf Wiedersehen. And that's now encoded in UTF-8. That's the default in Python. Let's just decode it into encode it. So now it's so maybe we should write that in the comment. Handle a single request and send it back as a byte sequence. As a byte sequence. Okay, and now we just return it. Return response. So this gets something. So we have the response. Okay, and now we have to send back the response. How do we send it back? Sending it back, it's quite convenient. Now the lower level you do this in C++, you would have to write, I don't know, 30 lines for this. So this can also be more. So this is not the lowest level you can do it. This you have to do low level because it depends on the protocol. What do you want? When do you want to stop listening? But here it's just send all. So here's my response, just send it. And how the underlying network layer does it, it will send it in packets. Packets get lost. This is a layer we're not looking at today. We just assume there's a reliable way to send a lot of bytes. Okay, and let's close this. So this was one communication channel with this person who called. We listened to what they say. They made a pause at some point, and we said, okay, now we are not listening to you anymore. We did something with that request. We send it back. We put up the receiver. So now we should have, it's our first working. Yeah, now let's try that again. So now, hello. I have a request. Bam. Okay, thank you for hello. I have a request. Auf Wiedersehen. Okay, we have implemented the call center. Now, a pretty standard call center. Maybe let's be a bit more professional and add a new line here. Still no content, but it looks professional. So that's important nowadays. So let me just, hello, I have a request. Thank you for hello, I have a request. Auf Wiedersehen. Connection closed. It works, right? Okay, so we have implemented a functioning client-server loop. And it goes on forever, and now I can call again, right? Telnet is in the simplest form. It's just one call, and then it's closed. Looks good. Let's just check before we go one further if we missed anything here. Yeah, that's what we had. We had Telnet. Oh yeah, you can also do it via curl. CURL, but yeah, let's get into that later, and I think that's it. Okay, so now, that was basic socket communication. Now we go to what the browser does. Before we move on, is there any question about this simple program, which is really the foundation for everything else, and how it worked, and questions? Yes?
When you typed an empty line, Telnet was sending carriage return and not just line feed. Is it a Telnet thing, or why?
It was sending what?
If you press
Yeah, let's just do it again. So what did I do? So please help me. And now? No.
If you press enter now, you will send carriage return, right? That's
Yeah, apparently. Otherwise, this wouldn't have worked. So, yeah, that's kind of the standard, that you send always these 2 characters. Because,
Telnet decides that.
yeah, apparently. Probably there's an option for this, but otherwise this wouldn't have worked. So it actually sent a new line as 2 characters, because that was just the standard back in the 17th century when these standards were invented. Yes, otherwise it wouldn't have worked, because we just move on until we find that sequence. Any other questions about this basic back and forth? Everything else now builds on top of it, and it's not harder. And let's just go on. Now comes something very interesting, which I think many people, especially people without a technical background, don't understand. What does a browser do? A browser is just a program where you type something in and then you get something and you can click on things. But a browser is actually essentially the same thing as Telnet. So I can, if I write this here, if I write Tura : 888, then thank you for Auf Wiedersehen, right? So I type Tura, so this is doing the exact same thing. So it's very easy to understand. In case you didn't know it, you know it now. So I now just got something from a machine, and that's now a different machine, and that's the machine where this browser is running. It's yet another machine, can be a machine anywhere in the world, and just by typing this in the browser, it now sends something to that machine on that port. It's the exact same thing we have just been doing, except that it's now sending me a whole lot of junk, or it looks like, and it's sending me this whole thing. And that it says get/http host user agent blah, so it's telling me who they are. I didn't ask for it, they're telling me anyway. It's telling me I'm speaking this language, this encoding, keep me alive, please, please, priority, blah, blah. Okay, so what's this? And this is now just a protocol called HTTP, and a protocol is really just, I want something from you and I send something to you, you have to agree on a common language. And that's just the language browsers use, and also other programs, HTTP, Hypertext Transfer Protocol. And this is one sort of request called a GET request, is where you want something. It's pretty similar to what we have seen. A GET request is, and this is what I want slash. Let me just, if I type something here, now it just sent me XXX. So this essentially what this says, give me XXX. So that's what the browser does. So now you know, it's very easy to understand what we have done before. If you type something here, what it does is it interprets the first part as a machine name. This is a port, and this is what it wants from you. So it calls up Tura on port 8888 and says, give me XXX. That's what it does, no more and no less. So, and now let's, and actually I'm getting it here, right? It says, so you want XXX, thank you for blah blah, auf Wiedersehen. First thing is, we are not interested in these headers here. Let's write a little code that just extracts this part. We don't want all the rest. So let's just do that. So okay, let's go to our handle request, and now let's even go here, and we are only interested in get requests and the part between. It's helping me here, get, and yeah, and actually I also don't want the initial slash. It will always, whatever it sends me will always start with a slash. I'm not interested in that. It will always be get slash, and then everything I typed after the slash in the URL, then this part I'm interested in that, and then this is the name of the protocol, and these are called headers. We will see it in a second. So let's just, okay, request, this, can't we do this simpler in one line? Yeah, let me just, yeah, we're not so interested in that. Let's just see in the, thank you for XXX, auf Wiedersehen. So now I'm just extracting that part, and let's maybe put, I'm very sorry, quotes around it. Oh my. Yeah. And now, yeah. So now let's go back to the slide. So now you know what a browser is doing. Let's, so that's used by the browser, also by others. So it's a protocol you can also use for other to communicate with a server. So we are now writing a little server, and the browser is talking to us. That's how the typical request is looking like. So the HTTP here was implicit. Actually, let me just clarify that maybe. Because I'm in a local network, I could write that, but I could have also written that. Does it work? Yeah, that, no, now I, HTTP : //tura : 888/xxx. Yes, so that's exactly the same thing. The HTTP was just removed here. So, and now, okay, now there's also protocol for sending things back, but before, let me just, so here I'm seeing what happens on the server side. Let's also look at what's happening on the client side. And I have something, what I did here, I pressed F12. It's also on the slides. Let me, yeah, there's a development console, which is super useful, and I tell you a little bit about it, and you absolutely need it for the sheet, and whenever you do something with it. You always get it with F12, and then there's another shortcut which depends on the machine. And important sections are network, for example, and I will show you other sections in a second. So here, many different tabs. Console is, you can actually, yeah, we will see that later, network. So let's now, bam. So now I see here in the network tab, when I do reload, this is what the browser, these are the communications, the things, the calls the browser is making. So it's actually making two things here. It's asking for XXX, and that's what it's doing here. So we see these headers. So if I do raw here, this is exactly what I saw, what was received, right? This is, because I type this in the browser and click return or send, this is what it's sending. It's called the request headers, and they are like one line per header. In raw, they look like this. In not raw, now they're just nicely formatted. And here's the response. The response now is just plain text, and now we do the next best thing, and that is also sending proper headers. So let's do that. And let's first go to the slide. So it's a bit, and when you send a response in that protocol, it's also pretty simple stuff. That's like the minimal. You say, okay, I understand you're talking to me in HTTP using this protocol, a GET request. I'm also sending back, okay, this is an answer, HTTP 11, status code, everything went fine, okay. I'm now sending you my response. The length has so many bytes. And this is how you should interpret that response. And we will talk about that in a second. So for now, we are just sending text, and let's just add these headers. So let's just headers. The headers for our response. And let me just, so headers, let's start. The first one is, it was this. Yeah, let's just do this. And now let's add the content length. So we already encoded it, which means it's now a byte string. So we have, and let's, the content type, so text plain. Maybe let's talk about that right away. Or maybe not. Let's do that in a second. And what else? Connection close. Okay, let me add connection close and let me return. So now I return the header. Again, I put an empty line. That's part of the protocol. First the header, then an empty line, so that the other side knows that's where the header ends. That's how you do it. So very low level, very primitive. I have to encode that as a byte sequence and the response. And now let's just do that. And go back to the browser. So, same thing. Thank you for XXX. Auf Wiedersehen. Let's go here. And now I should see response headers here. Those are the response headers I sent. And here we have 200 OK. It's just what we sent. And just to show you how primitive this is, I could also send something else here. Alles klar. Alles klar. It's so simple, right? And it's really, this is simple stuff, but I think it's, if you have never seen this so far or only have a rough understanding, I really encourage you to play around with this. But that's what's happening underneath. If you are in a browser sending requests, you get result. It's just these requests, responses, sending back and forth, and these development tools are great to see what's being sent back and forth. It's super useful. And of course there's a lot more, but we will just talk about the core here. So there is, what's the next thing we do? Let's just, one more thing before the break. So we have this, that's how we send our response. So we are just sending GET requests. Let's not get into that. We just send, that's one type of request. You can also send POST requests and many more. Then when you send something back, typically you say 200 OK when it works. You can also say 404 not found, or 403 forbidden, go away. There are some standards for this. So you should, these are pretty common. You are asking for something, I'm telling you, sorry, it's not here. I'm telling you, maybe it's here, but I'm not giving it to you. So these are very typical, and then there are many more. So we saw MIME types. Now that's another thing. I think now it's time for this comment, which is super important and what this whole sheet is about and what I'm showing you here. Every single thing we did here is super simple. It's so simple, right? I'm getting something, a header, a GET request, which is just a line with a string. I'm just extracting the part between the data. It's very simple, but there are so many things happening here, right? And so many different standards and protocols. So I have one machine talking to this machine. I have network communication. I have to pay attention that I'm still there while the other side is still talking. Then I have these headers. There are standards for this. And now I have this text plain thing, which is telling what I'm sending you, please interpret it as something. And now this is a standard which predates the standard for how should you interpret the bytes I'm sending, which is why it was originally called MIME types, multi-purpose internet mail extensions. When you send mails on a low level, you also just send bytes, but you just have to tell the program, oh, this is actually a PDF, this is a text message, this is an image, whatever. And so here are some examples. So you could say, this is text, HTML, we will talk about in a second. This is an image, this is JavaScript, this is whatever. There are hundreds of them. So they used to be called MIME types because they were designed for mails. Nowadays they're called media types, and for HTTP they're called content types, and it's all the same. So that's one thing about this whole thing, many names for the same things, a lot of history, which is why some things are a bit strange, but for backwards compatibility we still do them. So let's just make this a little bit nicer here. Let me do some, because we want to do a little bit more. So I'm always using UTF-8. There are also many other encodings. Let's, the HTTP code, somebody talking to me here. Let me just turn off the sound on this machine. We just do one more thing before the break. Let's just do, so that's 200, alles klar, okay. And let's, yeah, the content type, right, or media type. And I'm also, yeah, the car set should not be, I mean, that should be the encoding we are using, right? Yes. And let's just put this in here. HTTP, and now we're just making this a little bit more general. That's the HTTP code, and here we are. That's the, okay, we need an F here, format string. Yeah. Now it should still work. Maybe let's just check whether everything still works. Everything still works. There's one curious thing here. I mean, there are always two. I'm sending one request. I say, please give me XXX. It's also sending this one here. What's going on? Do you have an idea? Yes?
I think it's requesting the small icon in the chat bar.
Yes, exactly. So it's always when I'm sending something, do you have some small icon which I can explain, display here to the right? It's called fav icon ICO, and there's actually, you saw it here, there's a media type for this, image X icon, ICO image. If I don't send something, the browser is very lenient in this respect, we'll just accept it. So if we go on here, actually I got something, and what I got was, what did I send back? Well, I sent back, thank you for fav icon, auf Wiedersehen. And the browser says, okay, but it's not showing me any errors or anything, right? That's very typical for browsers. The other side does all kinds of strange things, but it just accepts it. I don't even get an error message. So it's just, okay, this is apparently not an icon. I'm not displaying anything. If you wonder, okay, user agent. I think it's a good time to make a break, and then we continue after the break. So 10 minutes, and we can open the window. Here's our code. Any question that occurred to you during the break before we continue? Okay, next thing we do. So far, we did the typical call center thing. So thank you for XXX, but we didn't provide any help. Now let's do something. Let's interpret this as a file. Let's see if there's a file with that name on our system, and if there is, return it, because that's one typical way how you use GET requests. And let's try to code that, and that should go in our so, and let's do that here, maybe. If a file with that name exists, and if yes, return it. Okay, so how do we do that? If okay, so if path, I'm using the path library here from Python. That's just one way to, details of that are not important. That's just checking if I consider this as a file, does it exist on the machine and is a file? If yes, I just open it. It's a bit confusing to call it request, so let me just call it file name. That's now, and then open. No, it's just request. Lower? Why should it be lower? So you see, I deliberately turn on this suggestion. Sometimes they are useful if you are very good with this stuff. Otherwise, they can be very confusing, right? A lot of suggestions which don't really make sense, do way too much, lead you in the wrong direction. So, yeah, you have to be careful with those. So I'm just reading this here, and now I have the file name and returning it. And if this is not the case, then I say, thank you. Okay, so now I have, so I'm checking, and let me just, so if this exists, serving file. What's the right? So I found a file, I'm serving it. Yeah, yeah, and just say thank you. Yeah, I don't need this. Okay, let's just see how that works. It still works. Now okay, XXX is not there. So what files do we have on our machine? We have search server.py. Or let's just let's just create a file. No, let's go here and create some message.txt, and that's let's just say Merry Christmas. So, and let's just try that. So now and that's more like what a browser typically does. So I type something here, which is really a path on my machine. And now let's see. Okay, what went wrong? So far, things have been going too smoothly. I should insert a few mistakes. What went wrong? Because you will encounter all of these mistakes. And actually, the development console helps you. We're having trouble finding that site. What do you think went wrong? Yeah, maybe somebody else. I will default to you if nobody else answers. There are more people in. Yes? We send a post request. Let's just see what it sent. We can go here. It's red. Red is headers. So it sent these request headers. And then it's no response. What went wrong? I have to wait for someone else. What went wrong? Maybe let's try it again. This is what we will do for the exercise sheet. Just trying again, but hoping that for some reason it will go away. What went wrong? Yes? The server is not running, right? It's very simple. I mean, the server is not running, so I have to run the... As I said, it's very simple, but you can easily get confused because it's so many different things. So, Merry Christmas. There we go. Great. So now we've written a file server. Now I want to point you to one thing, and that is when you write a file server. Let's just do the following. It's a little bit small font here. What do you think will happen now? Yeah?
You didn't check and sanitize the path, so you can access really any file on the server.
So will I get that file now?
Probably yes.
Yes? It's the password file. Of course, there's no interesting information in there except for a few names, but I now got so dangerous, right? That's important, and we will talk about more in that lecture. I've just written, I mean, it looks so innocent. We didn't talk about that for databases. but we will come to that in the next lecture, like injection stuff. So I just wrote this innocent little code. Yeah, let's just check if there's file in this directory. I didn't think about that I can write an absolute path there. So with this server now, I'm just running my little test server. I'm exposing my whole file system. So let's maybe build that into it for now. So how do we do that? The very simple thing is to maybe, and let's maybe, if, yeah, let's just look if this is in the request, and I don't want the other stuff. And now let's then maybe let's do HTTP forbiddenness. Let's just say go away. And let's just, so what's our response? Yeah, no, that is too political. That was sneaky. Okay. But we don't give it to you. That was sneaky. Encode as UTF-8. If, else, we do this. So we have now, you see it's already getting more complicated, but still the same. So we have our standard encoding, our standard return code, our standard content type. Here I'm just standing the code, and maybe that already works. Let's just try that. And I've already, yeah, that was sneaky. And now if I go here, I actually get 403 go away. Yeah, so we solved it. The question is, did we fully solve it? Maybe there's another. We just checked whether there's a slash in there. Yes?
I think if you run the server under Windows, you could still slip because the path separator is a backslash.
Yes, exactly. So there are other ways. There could be a backslash. Maybe you could encode it in a percent encoding, blah, blah, blah. So it's not that easy. It's actually part of this or the next sheet to do it properly. Yes?
Maybe we can also use dot.
Yes, dot, but when you use dot, you need a slash, yeah. So it's actually not that easy, right? One very safe approach is to just have a whitelist. You can just have exactly these files. If it's not exactly in there, I will not do it. But now it's the realm of security, and yeah, there's a lot you can do wrong. Yeah, you write a very simple program, you didn't even think about it, and then it can be exploited. That's the reason for so many exploits. People just didn't think about that. Okay, now here's another new concept. So as I'm saying, this is mostly simple concepts combined together. Here's a language when I want a nice web page. It's called HTML, which you have maybe heard. And we will now write a very simple HTML page, namely our search page. So search HTML. And HTML looks as follows. It's some, and here I have a head, and so it's just XML-like, and I have a body. And let me, my first search engine, or our first search engine. And then, let's just close all kinds of funny suggestions here. HTML, and there's this at the top, I think. Oh, why is this not working? What should be at the top here? It's this doc type thing, right? It's on the slide. Doc type HTML. Yeah, now I'm saying this is proper HTML. And now I have a, so what I'm saying here, head, I will talk about that in a second. Just put something, and this is now markup. This says, put this, render it as a first level heading. And I call it search HTML. HTML is a hypertext markup language. Markup language is just I'm putting in my text file how to format things. And let's just do that here. So now search HTML is in the, oh, that's here. Let's just see what we get. And now we get this. So we get a nice web page with a first level heading. So actually I want my browser to interpret it, but it didn't. What went wrong? So you know it, but I need somebody here. Yeah, I need to send the content type. So actually, again, I can verify it here. It says, I sent this as text plain, so it's showing to me as text plain, right? Imagine I send an image, which is just a byte sequence, then I will just see the byte sequence here rendered as text. I have to say, how should the browser interpret it? It should interpret this as HTML, but the way we have written our code, this is now very simple. How would you do it? Where? What would be the... So I'm sorry that I'm waiting for others, because you appear to know all this stuff already, but I will always default to you if I don't get an answer in. Yes, 30 seconds. Yes? What do you mean in the header? Yeah, the content type. But how do we set the content type? How do I do it? So it's text plain. I mean, if I now just put HTML, everything will be HTML. Well, what's the right way to do it in this code? I mean, this is the request we got here. We got a request for this. Yes?
We need to override it.
Yeah, we need to overwrite it, and when and how? Mm-hmm. In line 84.
The next line after.
And what do you... I'm ready to type whatever you tell me.
Content type equals text HTML.
Okay, but do you also unconditionally?
So we could check the suffix of the file.
Okay, check the suffix, yeah. So if this ends with HTML, that's what the suffix are for. Then maybe do it that way. I agree. So good collaboration. So let's, if ends with HTML, then content type is this. Let's just do that, whatever the, yeah. And now let's try that. We have to, wow. Okay, our first, and this is how web pages looked like in the 80s, and how web pages of researchers still look today, because they kind of, yeah, so you can tell the age of a person by their web page, basically. So let's just do, maybe make it, emphasize this. So this is, 1990s look and feel. Is it 90s? Yeah, it's 90s. So why is the end highlighted? Because I have to escape it, right? This is so another concept. In HTML you have escape special characters, and this is just the ampersand. So let's just do that. Question. Do I have to restart my server or not? That's another interesting detail.
No.
Why not?
Because the server just accesses the file system.
Yeah, the server just accesses. I changed the file now, so this is also something to understand. I changed something. What do I have to restart? What do I not have to restart? That quickly becomes complicated for web application. It's a good test for whether you really understood it. I just changed the HTML page. My server is doing what it's doing. If I do reload now, it will just reload the new page. I didn't change anything about the server. So 1990s look and feel. Great. So, and let's add a little more. So now our server is fine. Let's just add a little more. Let's add an input field. And maybe, okay, so here we have some suggestions. That's actually not bad. So it's, yeah, let's be, what do you want? What do you want? Let's, I'm deleting a bit too much here. ID is query. What do you want? Let's just do that. Now we have an input field. Okay. Tell me what you want. And now we want a search button, maybe to the right of it. It can be, yeah, that's also. No, I don't want on click. The suggestions are, yeah. Now I get a button. That's just HTML stuff. There's some of it on the page, but you easily... Oh, now I have... That's basically how web pages looked like in the 1990s. So I have something here. So next thing. Now we have a few more things left. And so one, where do I go? So that's HTML. And of course, there's a lot here. What did we do so far? Let's talk about the head real quick. We didn't put anything in the head here. So what we did so far, we said this goes on the page. This is our heading. But in the browser, here in the browser tab, it displays something. And we have control over that too. And this is what we put in the head. So the title we put in the head will be displayed here. So let me just do that. The title... No, I want the same title. Our first search engine. So this is now in the title. This is what's on the page. This is in the metadata. And I would now expect that this changes to our first search engine. And it does. So yeah, again, easy to understand, but there are all these little details. Next thing, and you can also, there's more information here. So now we want to add style. So this is 1990. Now let's make it 1991 by adding some colors. And you can do that with style sheets. And for the exercise sheet, you can do a bit more. So what you can do here, and that's very typical, I'm linking yet another file, style.css. And by just writing this in the HTML, it will try to load style CSS, and let's just write that. And let's do the following. Now I'm saying H1, please show it on, and let's choose a color from the 80s, magenta. Yeah, nobody uses magenta. In the 80s, you had magenta, cyan, and all these colors. For some, it had to do with the hardware, I think, that you had these. It was very limited what you could display. So now this just says, so that's again another format you have to learn, or, so you can say show all headers in blue and in a bold font and whatever. So CSS, it's the basic standard for layouting a web page. And it's good style to put it into a separate file. And there's a lot to say about CSS. I'm just explaining you that it exists, and you can go to any resource you want to see what's possible. So let's do that and reload it. And it's not magenta. Why is it not magenta? What went wrong? So here's another thing we haven't seen. The console just gives me feedback. We haven't looked there because everything was going smooth. So what does this mean? It basically says what it's...
We need to send CSS, text CSS.
Yeah, exactly. It just loaded the style CSS as text plain, and then it says, that this is not text. This is I should interpret it as a style sheet. Before I do that, let me show you one more sneaky thing here. It's one of these millions of details, but you should... If I remove the doc type here... Okay, I don't know why everything turns... It's because I wrote magenta in the other tab. So let me just do this. Now it works. That's again, right? So, and it says here, this is Quarks mode. So if you don't write this there, then the browser will accept. It will just try to make sense of whatever you write there. So you should do this. Now it says be strict. If you don't do something properly, I will not, for example, the CSS does not have the same right MIME type. If I remove it, it will be very generous or try to be generous. So now we have to change our server, and that's very easy now. It's always the same thing in computer science, right? Once you have the basics and you have it all properly done, it's very easy to add more complexity. So now it's, so here it's proposing JPEG. I'm not interested in that. I just want CSS. Then I just do this. And I'm not sure why it's getting the indentation wrong. Maybe I should. Excuse me, which line? What's wrong?
It wasn't at line 80.
Line is something wrong, or?
Now
Now it's fine, but the rough formatter is, what is it comparing? File name is assigned but never used. Okay, that's true. Let me just use it here. Okay. Yeah, and I could, yeah, doesn't matter. Okay, does it format now? Yes, now it. Okay, so now it should, and did we change that? Yes, I put it here, so I say please be strict whenever something is not quite right. Plain is, okay, it's still wrong. Why is it wrong? What happened now? I didn't restart the server. You see, it's so easy to get something wrong. Just imagine yourself doing the sheet and you did it, and now, yeah, and it's maybe late and it doesn't work. Well, I really have to emphasize this for 10 seconds. This is the problem with this stuff. Every little detail is super easy, but in combination, it can be very confusing. Where is the error now? And the error is just, I didn't restart the server. But maybe I made a typo in my script. It's not in Quark, so it could be 10 different things. I didn't restart the server. And you just, and now it works. So now the console is clear. Network, it's now asking for 3 files, right? I typed search HTML, so we can understand, so it's requesting that. In the search HTML, there was a link to a style sheet, so it's also requesting that. It's getting it at text CSS, as it should, and it's also, like always, asking the... How do I get back here? How do I close this, by the way? Oh, this one. And it's asking for the fav icon. You can implement that, so if it's asking for that, just send something back and it will display a nice image. Any questions so far? Before we go to the, there's not so much more. Yeah, so make a web page, maybe go to 1993 or 2000, or, I mean, you can, web pages can be very nice. So in this lecture, we just go to 1992. So magenta styled heading. So what we haven't done now, 2 more things. I mean, I type something here. Nothing happens. I mean, I just put the buttons there, right? It's there, but it doesn't do anything. And also nothing happens here, right? When I click here, nothing. So now I have to say, and for this lecture, we do static web pages. So nothing happens in this page. It's just displayed. And when I do something, a new request is sent, and maybe I get a new page or not. And now the old way to do this, and you should at least have heard of that, is just to put a form around this. So web forms, this is how you would do web pages. Again, in the 90s, but I think it's important to, let me just put a form around this. I just changed the HTML, so I don't need to change this here. And why is it always showing me all this? Didn't I? Let me just change my server so that it shows less. I thought it was, oh, yeah. Just let me put the print here. I just want the, then the log is a bit cleaner. So now I got this search. I get 3 requests, right? And the typical web page, when you go there, it will make 500 requests, right? You go to a web page, and if we go to any web page now, and actually let's do that real quick. Let's go to the web page of Uni Freiburg here and click on it. Oh yeah, you see, now by just scrolling on the page, it already sent 1 million things. So if you want to know what's going on in your browser, open the F12. So now I'm opening the Uni Freiburg page. Okay, it's not responding, yeah. Now you see here, it's like asking for 94 pages. Just by going to the web page, it was sending 94 things, tracking, changing your marks in ISIN1, I don't know what. Yeah, it's doing all kinds of stuff in the background. So, and here we just sent 3 things and we received 3 things. So, now let's try to type something, blah, and it's still nothing is happening. Okay, we have to go to the slides. So this is when you want something to happen. So this is the submit button. This is just the label of the button called value. I need to put this name attribute here. So let's just do that. And this is just something you have to know, but it's a name query. And I think that should already work, and I don't have to restart my... Did it work? No, it didn't. Oh, I have to reload the page. Still didn't work. Why, what am I missing?
The input type is button. The input type is button and not submit.
Oh, it was not submit. Thank you. So I'm sorry for... Oh yeah, it's type button. Yeah. So you see it's very easy to... Okay, I don't have to restart the server. I have to reload it here. Let me just search. Now I got something. Okay, and now you see something new. So now I typed in a form on the HTML page, I typed something here, search, and I click on it, and now you even see it here, thanks to our nice thank you message, what it sent. Now it sends search HTML question mark query equals blah, and this is exactly what our server received. So that's the way how web forms work. It's basically what it's saying, give me the same page again, but now I'm sending you some payload data, some additional information, namely somebody asked a query equals blah. And let's just process that. Now let's just change our server to process that. And that will be almost the last thing we will be doing. And please think about any questions you have. And so let's do, so check if there is and for now we do it very basic, we just look for this string and then if yes, strip it and process it. So for now let's just, so if yeah, if this is in request, then let's just yeah, let's just do that. So I just take that's the query, and then I don't want, let me just strip it from the request too. Yeah, that's not nice code, but let's just do it. Or this I could do nicer, right? I could just request comma query and you tell me when something is wrong. If it's there, I don't do any error handling here, right? If it's not there, then the server will crash, I don't know what. And now let's, how do we process it? Let's just compute the 3 grams. How about that? Let's compute the 3 grams. Let's compute the 3 grams of the query string. So how do we do that? We call them qgrams. And let's put an array here. And now we just do a little loop for I in, yeah, that's good enough. And now we have our response is just 3 grams are, yeah, that's fine, just separated by comma. And then we usually, okay, and maybe now this should be in the else part, right? So that's our response, and now I'm sending that back as, yeah, let's just try that, but I should encode it, right? I think. Yeah. let's start our server again. Okay, blah is a bit boring. Freiburg im Freis, whatever. Yeah, so now I got back what I got back, but it's so now the last thing. So this is not quite what you would expect from a search engine to do, right? If you type something in Google, it's not you do not get back the results, but you kind of get the original page with the result, and the form syntax kind of indicates this. So if this says, when I click on this button here, it will actually say, give me the same page again, but do something with this. And this is the last thing we want to do now with static web pages. Give me the same page again, but do something with this. And the way how it was done in the 90s, and that's still useful for some stuff, let's just put some template here. Let's just put, let me just put something here, which I will then, which if I don't have any parameters, I will just replace this with nothing. If I have parameters, I will just replace it with the result. Let's just do that. And so I put something here, and that's just my own convenience, and I'm doing it super low level. Let me not put the... So I will just continue processing there. If there was a query, let me just process it and remember the result. So the query result is empty. If I'm in here, this is my query result. And maybe I should... No, we didn't have any encoding. You can do a lot of things wrong if you mix encoded and not encoded. For some reason, I didn't have any mistakes there so far. So what I'm doing now, if there is a query appended to my request, then I will just process this query, store it in query result, which will be empty if there is nothing. And then, when I serve my file, and maybe I could just do it right here. So, so if my file is, and that's file name, if my file name is search HTML, this is showing too much, then I just, no, I don't, should I do it? Yes. Then I will just replace the response. I will just replace. Is it that simple? Yeah, there's just this template thing in the response, right? And I will just replace it by query result. I'm not sure. Is this correct, what I did here? I compute the result. Let's just go here. So there's just this % result. If I don't do nothing with it, it will display on the page. But here I'm just saying, when I'm serving a file, and if it's search.html, just replace the result by either the empty string, if there was no query something in the result, or by the result of that. Maybe it works. Let's just try it. Finally, we have 1 bytes versus this errors you will also get. So where did we go wrong? Oh yeah, response replace a bytes-like object is required, not str. Okay, so one of these was not a bytes-like object. Which one? You tell me where it went wrong. It's the last thing, and then we Why do I get this error message? I also am not. Yeah?
We read the file, so we get back bytes.
Yeah, we get back.
Response dot replace, response is bytes, but the string percentage result is just a normal string.
You think that's the problem?
Yes.
Very good. Yeah, I also think that's it, but tricky, right? And this, you will encounter this. And this is a real problem. It's not just because we did it all so hacky. You always have this difference between bytes. When you send over the network, it's always raw bytes, and then you have to interpret them. And when you mix them, you get into trouble. So it's actually correct that it would be bad if it would have just done something, because then terrible things can happen. So let's see if that solved the problem. And you need to understand quite a bit too. Yeah, and then you get these error messages. Wow. Not bad. So now, did you see what it did? So what it did, let me just go to the page here. It just returned the same page again because it appended the query equals something, computed something, and just replaced this here. And also, let me just go back here. I don't see the, yeah, if I, okay, something went wrong. Why did this happen? Okay, it doesn't work if I don't have a query parameter here. Why is that? Okay, I have an idea. Do you also have an idea? If I don't have, yes?
Initialize it to a string of the bytes.
Yes, exactly. Yes, so this is, yeah, if I don't, yeah, this was just a string, not bytes. Yeah, so now now our Kreisbau. Okay, so now it works. The query disappeared. We could also write the query, but that's fine. We have a few more things here, and then we are done. I'm afraid we will finish on time. I'm very sorry for that, for the confusion. So first, lowercase. That's easy to fix. Where's lowercase? Where's my query? Here. Query is query.lower. That should fix that. I have to restart the server because I changed the code. We are pros now. Yeah, now it's, see, by just reloading, I get the page with the result because it's here. It's already appended. Let me make this a bit bigger now. We don't need this back and forth. So it's actually in the, and when you, I mean, this is how you did it in the 90s, but when I search something here, Google still does this, right? So now I get the same page again here. I know it's a bit small. Search, question mark, query is Breifurg im Kreisbau. So it's the same thing still, right? The typical mode is you get back the same page with the search result. So yes, it's still the default mode. In the next lecture, we will change the page dynamically while you're doing something. It's not reloaded, it's just changed in the browser, but the standard mode for most is still what we see here. So it's actually sending you a new page, which is the same page with search results. We're doing the same thing here. So last thing we have to solve is, well, I didn't write plus here. And also, yeah, the query thing, I think let's just solve that as well. Maybe I should put, where should I put the, oh, it's here, right? Maybe I should put that here. Query. So that way I also have the, I mean, it's kind of strange that the query disappears. I reloaded the page. It says, what do you want? 3 grams? Maybe I want the query in here. So let me, and I think maybe I should put that here and not lowercase the query. Query lower, does that work? And now I also, so if I don't have the query, I should also, no, here I should put what do you want? I could also do the encoding later, and then maybe here I should put the same thing for query, right? Will it work? Let's just check if it works. So I'm going a little bit faster now. Oh no, what? Bytes like, oh, I know what happened. Where's the, oh yeah, now it didn't, so I should also encode the query here if I, it's not nice code we're writing, but it looks like it's work. Okay, now it's, okay, and there it says Freiburg im Breisgau. Okay, and let's just start with the page. So here it says, what do you want? And typos are fine. It's lowercase, it's 3 grams, but now we have the pluses here. That's the last topic. Actually, you can see it here, and if I make the browser even a bit larger, the thing is, what I typed in the query is now encoded in the URL. And that's now I can also explain you very briefly what's the difference between a GET request and a POST request. In a GET request, the payload, like the message I'm sending, is part of the URL. And you all know that from these long tracking URLs. When you are on social media, you click on something and you will have question marks, something very long which identifies you, tracks you. So it's part of the URL. In the URL, you can't have space. Actually, you're pretty restricted in what you can have on a URL. You're restricted to these characters. It's very basic. So no funny characters like umlauts or dollars, percent is definitely no space. And so one standard, and now you have to, so when you have some general text, you have to encode it as a URL. And that's something we will talk more about in the next lecture. So there's percent encoding. Percent is allowed, and then you just put the hex code of whatever it is, or the space becomes a plus. So we just do something very simple here. We just convert the plus back to a space, and then it should work. And for the exercise sheet, you can do more. So we have to do it in the right place. Where do I have to do it? Maybe we should do that right here. And actually, we should also have seen it here. Yeah, here it's already plus. But actually, we only want it for the query, right? The rest we don't care. So let's just do query, replace the query with pluses, and let's see whether it works now. Yeah. Now it's done. Maybe we should put quotes around our, and that's the last thing we do. Append F Qgram. And I think that's it, and please do, yeah, now we have a pretty good web application already, and it works, no errors. Not bad, right? Let's see if there's anything on the slide. Yeah, if you're working on this connections, you can close them after each request, keep them alive. There's something here, just so you know it. We are on time. I'm very sorry. We have time for a few questions. So we've gone round trip, one whole time. Questions?
One simple suggestion for better user experience.
Yeah. Oh, that's true. Yeah, that's a good observation. Yeah. So right now the query is here, but if I now go there, I can't reuse it, right? Because it's just a placeholder. So that was a bad idea. And what it should be the value, right?
Yes, there's an attribute called value, and when we set it, we set the value, not the placeholder.
So it should be here, right?
Yes.
Okay.
We can change the placeholder back to what we had previously.
What do you want?
In the Python code, we can remove that.
Perfect.
What do you want?
Yeah, we can just, which is anyway weird to have it in the Python code, right? That's a great improvement, yes, and we can just change that here, right? That's your suggestion, right?
Yes.
Perfect. And now it's, yeah, now we can edit it. And if we remove it here, we should get the placeholder, right? Yes. Perfect. Great suggestion. Any other questions or comments? Yes, please.
Could you switch to a code where the socket is and the request?
Up here?
Yeah.
Yes?
And why do we close the connection after receiving the request and don't just listen?
Okay, that's a very good question. What are we closing here? There are two there's the socket of the server. This is not closed. This is where we are listening, our phone. This is the communication channel with the browser talking to us, or with whoever called us once. One iteration of the loop, somebody's calling us, asking us something, we give them something, we put up the receiver, and then in the next round we wait for the next call. This is putting up the receiver. Does it answer your question, or not sure? So this is not server socket close, it's client socket close. So it's putting up my receiver, but essentially I'm saying I'm done talking to you. It's not, the server socket is not closed in the loop, that remains open. Any other questions? Okay, so it's now, we have this strange situation that we still have a Tuesday before Christmas, but no lecture. And then the first Tuesday after the break is this funny holiday where there's also no lecture. So 3 weeks, we see each other in 4 weeks. So it's 4 weeks, and then we go on. Okay, so I wish you a great holiday and see you in 4 weeks. Bye-bye.